Hey guys, this is the review lecture for Exam 2, Math 095. This will probably be fairly long, so I'm going to try to go relatively quickly as I get through this. So for the test, if you have me, you're going to have this on your sheet of notes, and then you're also going to have the table with the squares and the cubes and fourths and fifths for the set of notes. So, properties of exponents, they're going to show up a little bit later in 8.1, but we start with some of these fractional exponents. Remember, that was this property up here where we have, basically it comes out x to the power over root. So, looking at 8 to the 2/3, this would be a cube root and a square. So, cube root 8, quantity squared. Cube root of 8 is 2, and then squared would make 4. 81 to the negative 3/4. For that one, it's going to use property, where to go, right here, 4. And that's when we have a negative exponent, we write it as 1 over. So that would look like 1 over 81 to the 3/4. And then that's going to be the fourth root and cubed. So 1 over the fourth root of 81 cubed. Fourth root of 81 is 3, and then cubed make 3 cubed is 27. This one, so this is using property 2, and so that's when we're raising something to a power we multiply. So I'm going to multiply the 6 into the exponents, and that'll give me x to the negative 6, and then 2/3 times 6 would be y to the 4th, and then x to the 1/2 downstairs. More than one way to do this. I would probably move this x downstairs and write it as y to the 4th. And since that's negative, I can bring it downstairs, make it x to the 6th, x to the 1/2. And if you think down here, you're going to be adding the exponents because you're multiplying. So basically, we have to do 6 plus 1/2, and that would be a little 2 over 2 right there. So that is, and this is all x raised to. X raised to the 12 halves plus 1/2, so that'll be x to the 13 halves. So here we end up with y to the 4th, sorry that got a little messy in there, and x to the 13 halves. For number 4, we'd be using property 3, which is going to be when we divide, we subtract. So here we'd have x to the 2/3 minus 8/3, and y to the 4/3 minus 1/2. X's already have a common denominator, so they're cool. For y, though, I need to do 3 over 3 right here and 2 over 2 right there, so that I can get both in terms of 6. So for x, 2 minus 8 would give me negative 6/3, and then y to the 8/6 minus 3/6. This would be x to the negative 2, y to the 5/6. And then this is negative, so I'll drop it downstairs. And there, I get that. For this one, I think it's easier if you rewrite it. Oops, not so good. Y to the 2/3, z to the 4/7. Just the way the exponents look this way, it's hard to see what matches up. And if I write it that way, it's easier to see that I'm multiplying the denominators. So you can reduce as you go. I think I'll go ahead and show all the steps. So this would go x to the 1/8, and you could just go straight to 1/3 there. You know, I really just want to go straight to 1/3 because this would end up 2/6, then you reduce the 2's, and it'll be 1/3. And then here, z to the 2 goes into 4 twice, so z to the 2/7. Okay, these next 6 are the ones that have you guys try in class. So 8 to the 4/3 would be 8 to the, it'd be a cube root to the 4th. So cube root 8 raised to the 4th, and that would be 2 to the 4th, or 16. 25 to the negative 3 halves. So I'm going to think of that as 1 over 25 to the 3 halves. And that'll be a square root and a cube. So that'd be 1 over square root 25 cubed. So that equals 1 over 5 cubed, or 1 over 125. This next one, everything's x's, so I should be able to get it down to just 1x at the end. with some exponent. So let's see, we have a lot of different things going there. I'm looking at the 3/4, 1/3, and 7/12, and I think I'll write everything just in terms of twelfths, just because I think that'll make it easier. So for the numerator, that 3/4, I'm going to say 3/4 times 3/3 for that x, and then the 1/3, I'm going to write 1/3 times 4/4, and that's still over this x to the 7/12. So that's going to make x to the 9/12, x to the 4/12, and x to the 7/12. Combining the numerator, I get x to the 13/12 over x to the 7/12, and then this is division, so we subtract. So x to the 13/12 minus 7/12, and 13 minus 7 will be 6, so that's x to the 6/12, and then finally x to the 1/2. So let's see this next one. I can do 1/4 times 12, and that will get me x to the 3rd. And I can go 1/4 times 2, so that would be 2/4 or y to the 1/2. And that's over y to the 5/6. So 1/2 minus 5/6 is what I'd have to do there. So x cubed, and then y to the 1/2 minus 5/6. I'll slip a little 3/3 right here. So that gives me x cubed, y to the 3/6 minus 5/6. So that's x cubed, and y to the negative 2/6, which is x cubed, y to the negative 1/3, and then finally x cubed up top, and y to the 1/3 below. Okay, so this one has x's and y's, so we'd have x to the 2/3 minus 5/6, and y to the 10/3 minus 1/3. And so right here I need sixths, so I'm going to do 2/2. And it's going to give x to the 4/6 minus 5/6, and y to the 9/3. Those two together give me x to the negative 1/6, and then 9/3 would give me a 3, and then reducing I get y cubed up top and x to the 1/6 in the denominator, or simplifying, I guess. Here, so same thing, I'm going to rewrite it just to make it a little bit easier to look at. That's all raised to the 1/3. So then here, 3 would go into 6 twice, so this would be x to the 2/5. And you can stop off at 6/15 if you want, you just have to reduce then. 1/3 times 1/3, that would be y to the 1/9. And then on this one, the 3's would just cancel, and I would have z to the 1/2. Section 8.2, this is the chart I said at the top of the video that you would get for the exam if you're in my class. So we're simplifying radicals, and so this is the thing where we have to look for squares under the square root and get all those pulled out front, likewise cubes under the cube root, etc. So looking at this first one, 250, I looked down my list of squares, and that feels like a 25 and a 10, right? So if I do 25 times 10 under there, 25 I can pull out a 5, and then I always leave myself some space, and then 10 stays in. And this is where I kind of envision that little 2 right here. So 2 goes into 11 5 times, so 5 x's come out and 1 left over. 2 goes into 5 twice with 1 left over, so for every pair 1 comes out, so there'll be 2 y's out and 1 y left in. Cube root, so now we're looking down our list of cubes, and it's got to be 8, because that's 27 doesn't go in, 8's the only one small enough, so 8 times 7 right there. And so then I can pull a 2 out front from the 8, and I'll leave myself a bit of space, and that's going to leave a 7 on the inside. And then 3 goes into 9 3 times with none left over, so no more x's in here. 3 goes into 16 5 times with one y left over. And then 3 doesn't go into 2, so that's going to make that z squared. This next set of problems is about rationalizing denominators. And so the square roots, those are the friendly ones where you just multiply them by themselves. And then for this, the numerator would come out to 35x. That's still under a radical because I didn't take a root at all. Here, I would just think root 7x, and that makes 7x. And that's that thing, yet again, where we have root A makes A. Here, this is the hangman thing. So I kind of have 3 things under the radical, and I have a cube root, so I need 3 slots. And I have a 2, I have an x, and I have a pair of y's. So that means I need 2 more 2's, 2 more x's, and 1 more y. So I'll put that in here as a 1. Very clever form of 1. And because this is really just 1. So then the numerator is just what it is. And then the denominator, if I multiply all this out, and for this one I will, and then I'll stop after this, I would get 8x cubed y cubed, which is exactly what we're making, was groups of 3 of all these. And that's so that we're able to then take the cube root. So cube root 8, 2, cube root x, cubed x, cube root y, cubed y. And so basically just for each of these, if I take a cube root, 1's going to come out, so we get 2x and y right there. This one's a 4th root with 3 things, so I need 4 slots. And 27 we want to think of as 3 times 3 times 3, x cubed, and y squared. So then I can do 1 more 3, 1 more x, and 2 more y's in there. So we'll do, 4th root, 3's, x's, and y squared. So if I multiply that, 2 times 3 gets me a 6, and then xy squared. And then here, like I said, I'm taking the 4th root of 4 3's, 4 x's, and 4 y's, because that's what I just made this do. So it's just going to be 3xy. Okay, for number 6, this one, the denominator is a little more complicated, so I want to simplify that before I multiply and make it bigger. So I'm going to go 25 times 3 right there, and so it's going to let me bring out a 5 and an x cubed and a y. So the only thing left in there is the 3. And then downstairs, I haven't taken the root yet, so that's 11z. And then I can multiply top and bottom by 11z, 11z, and that's going to get me 5x cubed y, and then that'll be 33z. And then downstairs, 11z. The next 5 are the ones that I have you guys try. So this is 9 times 5. So I can take out a 3, leave some space. It'll save a 5 inside. That little invisible 2 goes into 14 7 times. 2 goes into 7 3 times with 1 left over. And then the next one, 4th root of 32, that is going to be 16 times 2. So 2 comes out, and then 2 stays in. 4 goes into 9 twice with 1 left over. 4 goes into 16, so that's y to the 4th. And 4 goes into 14 3 times with 2 left over. Okay, so this one, we'll do 2x, 2x, and we get 10x up top under the root, and root 2x will just make 2x. And remember, we can't cancel because this one's under a radical and this one is not. Hangman for this one, I got a 9, so I want to think of that as a pair of 3's, an x, and a couple of y's. So I'm going to need to put in 1 more 3, 2 more x's and 1 more y. So 3x squared y. So that gets us up top cube root 3x squared y. And then downstairs we have cube root all that. So it'll just be a 3, an x, and a y. For number 11, there is a 4th root, so we're getting 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. And 9 is going to be a pair of 3s, so we got a pair of x's and 3 y's. So we're going to put in 2 more 3s, 2 more x's, and 1 more y. And then multiplying, my numerator will just stay that, under a 4th root. And then downstairs, I'm just going to get a 3, an x, and a y from the 4th root. Number 12, I'd want to do the numerator first. So cube root of 27 is going to bring out a 3. 3 goes into 6 twice, so 2 x's come out. And there's not enough y's, so the y squared has to stay inside. And then downstairs, that leaves me 2z squared. Here, I have a 2 and a couple of z's, and so I need 2 more 2's and 1 more z. So 4 and z. And cleaning that up, I'm going to get 3x squared out front. Underneath the radical, I'll get 4y squared z. And then downstairs, we have 2's and z's, so I'm just going to get 2z. Section 8.3, we got adding and subtracting radical expressions. And so with these ones, these are the ones where they have to be like terms. And so a lot of times you kind of start with the easier the numbers and use that to find what's going to work for the rest. So like for instance with the 75, I find that one easier than 108 or 147. Just spot that it's 25 times 3. Once I see that, then I can go 3 into 147 and get 49 times 3, and 3 into 108 and get 36 times 3. So if I write that, this is going to go 2 out front, and then 36, so that's going to come out as 6 root 3, plus this is all under a radical, so square root of 49 will be 7 with a root 3, and square root of 25 will be, oops, that's a minus, 5 with a root 3. So this is 12 plus 7 would be 19, minus 5 would be 17 root 3's. Oops, sorry, 14. Sorry, it's late. The next one, let's see, we got 48, 12, and 27. So here I'm kind of seeing a 4 and a 3. Here I'm seeing a 9 and a 3, so 3's again, and a 16 and a 3. And then this time we also have to deal with x's. So square root of 16 is going to bring out a 4, and then I have an x squared, so I'll be an x. Root 3 stays in. I'm just going to write the 2x out, and square root of 4 is going to bring out a 2, and then 3 stays in. And square root of 9 is going to bring out a 3. And then we have an x squared, so I can bring out an x, and then 3 stays in. So cleaning that up, I'm going to get 4x cube root 3 minus 4x cube root 3 minus 15x cube root 3. The 4x's drop out, and what's left is the 15x cube root 3. Okay, so for this one we have some fractions. And so I think the first thing I'll do is, just looking at this 8, I'm going to rewrite it as 2 root 2. And then this is written kind of funky, so maybe I'll write that as square root 1 is just 1, the root 2 downstairs. And then I'm going to have to rationalize the denominator on this, so before I go any further, I'm going to slip in a root 2 over 2 right there. And then that's going to be plus root 2 over 2. So then I can kind of see I got 2's coming up. So what would probably make sense is to think of this as over 1. And this is going to be 2, this is going to be 2, so let's make this one 2 also while we're here. So 2 times 2 will be a 4 root 2 over 2, plus a root 2 makes 2, plus one more of those. And so this has the kind of invisible ones here. So it's 4 and then 5, 6, root 2's over 2, and then reducing I get, oops, and I wrote a 2 there, so 3 root 2's. Okay, and then these are the 3 I would have you guys try. So start with the easy number, probably 24, 4 times 6. 150 would be 25 times 6, and 54 would be 9 times 6. So here I'm going to bring out a 4, and that will make a 2 root 6. Here I'm bringing out a 5, so I'm going to say 3 times 5 root 6. And then there's that 2 there. I'm bringing out a 9, so it'll be times 3 root 6. Cleaning that up a little bit, I get 2 root 6 plus 15 root 6, and then minus 6 root 6. So 2 and 15 is 17 minus 6, so that should be 11 root 6. This one's similar. We got 8s and 50s, so it seems like it's going to go 4 and 2, 25 and 2, and then 4 and 2 again. So here I'll just write out the 5a. I'm bringing out a 4, so that'll be a 2 root 2, minus 6, I'm bringing out a 5. I can also bring out, and have to bring out an a, root 2 left behind. And here will be a 4 times a 2 and an a. And then this 2 is left behind on all of them. Cleaning that up a little bit, I'm going to get 10a root 2 minus 30a root 2 minus 8a root 2. And let's see, 10 minus 30 would be negative 20, and then down 8 more would be negative 28. A root 2's. And then number 6, we got fractions again. So I'm going to rationalize the denominator on this first round. I'm over here with it. So I'll make cube root 3 over 5 plus cube root 3 over 3. And then to get a common denominator, I'm going to do a 3 over 3 right there, and a 5 over 5 right here. So that'll get me 3 root 3 over 15 plus 5 root 3 over 15. So altogether, 8 root 3's over 15. Okay, in this section we got multiplication and division with radicals, and this is 8, 4. So here I can multiply these two together and get negative 15. So when we're multiplying these, I'm doing the 3 and the 5 together because they're outside the radical, and I'm doing the 6 and the 10 together because they're inside. This isn't a FOIL. This isn't, negative 5 times 3, negative 5 times 10. This is just a thing times a thing. It's just like saying negative 5x and then, negative or 3x or something, and 15 goes together and x's go together. So here, negative 15, root 60, and I need to reduce the 60. So that'll be negative 15, and 60 is 4 times 15, so I bring the 2 out, and that'll give me negative 30 root 5. Sorry, 15. There we go. This one is a FOIL, so I'm going to do first and then outer. So 2 times 3 in front would make root 6, and then root 2, I'll go ahead and write root 4 for a second. And then this times the 10, so there's that invisible 1, so 2 times 1 minus 2, and then 2 times 10, root 20's. On the inside, same idea, so I'll do this and this. So 1 times 3 is going to be 3 root 20's, and then 1 times root 10 would make minus root 100. Cleaning all this up a little bit, square root 4 is really a 2, so 2 times 6 is going to make that a 12. I have minus 3 root 20, or minus 2 plus 3 root 20, so that's plus a root 20. And then minus 100, root 100, so that'd be a 10 when it comes out. 12 minus 10 gives me 2, and this is a 4 times a 5 in there, so I'm going to say plus 2 and root 5. This one is, you could do it as a special product, but I think almost everyone will FOIL it, so I'm going to show it that way. So let me write this like this. And then I'm going to FOIL everything out. So root x plus 2 times root x plus 2 makes x plus 2. And on the outside, I'm going to get minus 3x root 2's, or x plus root 2's. Yeah, you know what I'm trying to say. And then on the inside, I'm going to get another 3 of those. And 3 times 3 on the end will make a positive 9 with the double negative. Combining like terms, I just have that lone x. Minus 3 makes minus 6 square root of x plus 2's. And then 2 and 9 for 11. This one, so this is that kind of dangerous problem where we have to remember that we need to multiply by the conjugate. And so, of the denominator. So I'm looking at the denominator, it's root 11 plus 3. So I want to use root 11 minus 3, which happens to be the numerator, but that's not the reason I'm doing it. I'm doing it to make the denominator not have a radical. So up top, it's another one of these kind of special products, which you can do it out that way, or you can just use FOIL, that's fine too. So root 11 would make 11, and I get minus 3 root 11's on the outside, same thing on the inside. Minus 3 times minus 3 for plus 9. And then downstairs, this is just going to go root 11 squared minus 3 squared, because it's an a plus b, a minus b, so it's going to make a squared minus b squared. Cleaning this up a bit, I got 11 and 9 for 20, and then down 3 root 11, down another 3 root 11's makes minus 6 root 11's. Square root 11 squared is 11 minus 9, and then I can make that into a 2. And remember, this is the thing where if we have the same thing that divides into all of these, I can go 2 into 2 once, 2 into 6 3 times, 2 into 20 10 times. So simplifying, I get 10 minus 3 root 11's. Okay, these would be the matched problems that have you guys try in class. So here we go negative 3 times 7 and get negative 21. Another way of looking at this rather than 150, so the last one I just multiplied and got the 60. You can also kind of go 3 times 5, 5 times 2. If that helps you see the pair of 5's in there. So it's just another way of thinking about it. And then 5 comes out. 3 times 2, 6 stays in. And then 21 times 5 gets us negative 105 root 6. This one we got some FOIL going on, so we're going to go 3 root 5 times root 5. So I'm going to think of that as 3, and then root 5 times root 5 is 5. And on the outside I have 2 times this, so the 2 would be multiplying the 3, but not the 5, because it's already multiplying the 3. And that would be plus 6 root 5. And then run the 4 through. So negative 4 times root 5 is just negative 4 root 5. Negative 4 times 2 is negative 8. So this is 15. 6 minus 4 makes plus 2 root 5's minus 8. And 15 minus 8 will give us a 7 plus 2 root 5. Okay, this is another FOIL, a little bit more complicated is all. So 3 root 6 times root 6, I'm going to think is 3 times 6, because root 6 will make that 6. 3 times root 6 times the root 2 is going to be minus 3 root 12's. 4 right here, root 12's. And then 4 times root 2 would make a plain 2. Cleaning this up, I got 18 plus root 12. Because we're down 3, up 4, so that'd be like 1, and then plus 8. 8 and 18 for 26, and then this is a 4 times a 3, so we'll take a 2 out, and 3 stays in. This one I'm going to rewrite as a FOIL, so root 5 minus 4, root 5 minus 4, and you really can do this the other way too. I should do at least one of them that way. So if I did this as the, thinking of it as a minus b squared, remember that's where it goes a times a, so root 5 would be 5, and then you do the a times b times 2, so 2 times 4 would be 8 times root 5, so minus 8 root 5, and then b squared on the end. That would be 16 from the 4 squared. And then 5 and 16 would be 21 minus a root 5. So I should get the same thing when I did it this way. So root 5 is 5. On the outside I get minus 4 root 5s. On the inside I get another 4 root 5s. And then minus and minus makes plus 16. 5 and 16 is our 21. Minus 4, 8 root 5s. These two are the multiplied by the conjugate to rationalize the denominator. And again, when you see this on the test, when you see the addition or subtraction, you have to remember this is the plan. Kind of without this step, there's absolutely nothing that you're writing that's remotely right, so there's not much for me to grade there. So you just gotta, when you see this, know to do that. And then also remember, we see these again in 8.6 with the complex numbers. So these two problems are very, very similar. So here I'm going to distribute the root 5. So root 5 times root 5 is plain 5, because it would be square root 25, and break down to that. Root 5 times 2, so negative 2 root 5. Downstairs I'm just going to say root 5 squared minus 2 squared. That's our a squared minus b squared. And this is going to be 5 minus 4, so that's just going to be a 1 down there. So this up top is my result. Over here, same idea. I'll do root 5 minus 1, root 5 minus 1. This time I do have to do a little bit of FOIL. So root 5 for 5. I get a minus root 5 on the outside, another one on the inside. Minus and minus makes plus 1. And this will be over square root 5 squared minus 1 squared. 5 and 1 would make 6. Minus one of these minus another one makes minus 2 root 5s. And this is 5 minus 1, so that would be 4. And this is another one of those ones where you can kind of see here, here, and here, everything's divisible by 2. So I'm going to knock a 2 out of everything. So 2 goes into 6 3 times. Here it go once, here it go twice. So it'll be 3 minus, you don't usually write the 1, so I'll just write a root 5 over 2. Okay, 8.5 is about equations. And remember with this, we do have kind of, this is a little bit more like chapter 7, where there's kind of a step-by-step plan. First step on these is isolate the radical. So we're going to go minus 2 on both sides. And that's going to get this radical all by itself. So 4x plus 3 under there equals 3. Step 2 is we square both sides of the equation. Watch out for FOIL, that's coming up on the next one. So I square both sides here, and then 4x plus 3 makes 9. And then if the equation is linear, I want to get the x's to one side and the equals and numbers to the other. So this one is linear, so I'm just kind of stripping everything away from the x. So minus 3, I got 4x equals 6, and then I'll divide both sides by 4. So that means that x equals 3/2. And then remember with these, you do have to check all your answers. I think I'm not going to show the checks just because it's not that exciting to watch. But if I put this here, it will come out to 5. If you want to try it, you can. It'd be 2 into 4 would be 2 times 3 is 6, plus 3 would be square root 9. Square root 9 would be 3 plus 2, and there's our 5. I'm not going to write that out for all. I'll show the ones where it matters, I guess. So this next one, I isolate the radical. It is square both sides of the equation. Watch out for FOIL. That's what this one is. So when I square this, I can't square the pieces. I have to square the whole side. And remember that a lot of times people write down x squared plus 1 there. And this means the same thing as x plus 1. Oops. x plus 1. So squaring does root, and I get x plus 7. Over here, foiling, I'm going to get x squared. On the outside, I'll get an x. On the inside, I'll get an x. So I'm just going to jump to the 2x there. And 1 times 1 is 1. So now we're at the, what kind of equation is it? This one's quadratic. So I want to get it to 0. And the 0 can be on the other side. In this case, it will be. And then we'll factor it, and then we'll solve from there. So I'm going to bring the x plus 7 over to the other side so I can get a 0. So I'll just subtract both of those. That all cancels, and I got 0 equals x squared plus x minus 6. And factoring that, I'm going to have x plus 3 and x minus 2. And then x equals negative 3, maybe. X equals 2, maybe. So this case, I'm going to show the check because it doesn't check, so I want you to see what that looks like. So negative 3 plus 7 equals negative 3 plus 1. So right there I'm getting a root equals a, it doesn't matter what this is. If this is negative 2, that's no good because roots can't equal negatives, and that's what this is saying. So this would be a 4. Square root 4 would make 2, doesn't equal 2. If I put the 2 in, I got 2 plus 7 equals 2 plus 1. Square root 9 makes 3. That one's true. So that's the good one. That's the extraneous one. Okay, so these next 4 are your guys's. So here, isolate the radical first. So plus 4, and that's going to make square root of 3x plus 1 equals 5. And then from there, I can square both sides. Square does root. 3x plus 1 equals 25. And then I'm just bringing stuff over. So minus 1 on both sides. And then divide the 3. And x equals 8. And I'll just say that one does check. This one, the best way to do it is to notice that it says square root of some math equals a negative number, and to write down D and E. You can do it out, and if you do, you'll get an answer, but much better to spot it right there. Okay, so this one, I want to isolate the radical, so I'm going to bring that x over to this side. I think it'll look better if I write it this way. 5x plus 1. Instead of 1 plus x, it just feels backwards, so I'm going to write x plus 1. And then I will square both sides of that. So that's going to get us 5x plus 1 over here. And this is that same FOIL, so it's went x squared plus 2x plus 1. And then I'm going to subtract over the 5x and the 1. So I get this equal to 0. So 0 equals, I'll be x squared minus 3x. And the 1's cancel. So this is the too easy, it's hard factoring, so it's going to be an x minus 3. So that gives me potential solutions of x equals 0 and x equals 3. And so if I put 0 in up here, I get square root of 1 equals 1, so that one's good. If I put 3 in, I get square root 16 equals 4, and that one's good. So both of those work. Number 6, I will square both sides on that. And I got 2x minus 7 equals, foiling this out, I'm just going to do the special products, x squared minus 6x plus 9. But if you need to, think of it as, instead of square, think of it like that, and just do your FOIL. Here I'm going to bring over the 2x and minus 7, so I'll go minus 2x plus 7. And then that gets me my 0. So that'll be 0 equals x squared minus 8x plus 16. So this would be, what multiplies 16 adds to be negative 8 would be negative 4. So I'll write x minus 4 squared. And then there's my factor, so this time I only have 1 0, and it's 0. And then if I'm sorry, it's not 0, it's 4. I don't know what I was thinking there. X equals 4, everything's good. If I put the 4 in here, I get 2 times 4 is 8 minus 7, so that'd be a 1. Square root 1 makes 4 minus 3, 1. So it checks. Okay, last section, complex numbers. So this is some addition, subtraction type problems, multiply, divide. So here I would just bring this down. I can really drop those parentheses because they're not doing much. That minus I'm going to hang on to for a second. And let me rewrite this as 5 minus 5i minus 2 minus 3i. And then instead of, I think I'll collect terms and then I'll clear the parentheses after that. So 5 minus 2 leave me 3, and then minus 5 minus 3 is minus 8i. And then I'm going to distribute that sign through, because remember that's like multiplying by a negative 1. So that makes this 8 minus 2i minus 3, and then minus minus makes plus 8i, and then just collect up the terms. So 5 and then plus 6i. Probably the number one mistake I see on this problem is people just kind of not reading the minus sign and thinking of it as though it were a FOIL. It's totally subtraction, so just be careful to do the math that's actually there. This next one is sort of reminding you of complex conjugates, so that's where we have a plus bi, a minus bi, and when I multiply these, they're going to come out to a squared plus b squared. So that would be 5 squared. And remember, b isn't 4i, b is just the number in front of I. So in this case, that's 4 squared. So that's 25 plus 16, or 41. Okay, this next one's a FOIL, so we're going to do first, outer, inner, last. So running the 1 across those, I just get those, so it'll be 5 minus 4i. And then multiplying by the 3i, I'm going to get plus 15i. 3 and 4 for negative 12i squared. Here, let's see, minus 4i plus 15i is going to give me 11i. And then remember that this negative, or I squared, equals negative 1. So what that does is flips the sign on the 12. And then I got a couple more like terms, so final answer for this is 17 plus 11i. And then, oops, one more. So the divide, this is the one that's like back in 8.4, where we multiply by the conjugate, but in this case, the complex conjugate. So 5 minus 3i, 5 minus 3i. So 2 times 5 is going to give me 10. 2 times 3 will give me 6i, negative. I times 5 will give me plus 5i. And then I times negative 3i, that would be minus 3i squared. Going to use the shortcut downstairs, so this is a plus bi, a minus bi. So that's going to be 5 squared plus 3 squared. Cleaning up my numerator, 10 minus 1i, or I, and then this I squared flips a sign there and gives me a plus 3. This will be 25 plus 9. And then finally 13 minus I, and that would be 34. Okay, and then these last 5 or so are for you guys. So 4 minus 3i, and then plus, this is going to go, I think I'll do this a little shorter, so 1 minus negative 2, so that's 1 plus 2, so that'll be a 3, minus 5 minus 3 is minus 8i. And I don't really need those parentheses anymore because it's an addition, so I can just 4 plus 3 will make 7, and minus 3 minus 8 will make minus 11i. Okay, and then this one we're adding, so that would just be 2 plus 1 makes 3, and negative 3 plus negative 5 makes negative 8i. And then here's that little invisible kind of negative 1s, we'll make that a minus 7, and a minus 10i. Collecting, I got negative 4 right there, down 8, and then down another 10 for minus 18i. Number 7 is a FOIL, so 5 times 2 for 10, 5 times 3 for minus 15i, plus 4i, and then that's minus 6i squared. 10 down 15 up 4 is minus 11i, and that's our negative 1s. That flips the sign on the 6. So 10 and 6 for 16, and then minus 11i. This one we're dividing, so we got to multiply by the conjugate. So 6 times 3 is 18i. And here that'll be 30i squared. Downstairs we're going to have 3 squared and then plus 5 squared. This will go 18i plus, actually, minus 30, because that's negative 1, and 9 and 25, so that'll be 34. I'm going to reduce, but before I do that, I'm going to switch the order of the numerator, just so it's an a plus bi form. And then I can knock a 2 out of everything. This is good as it's going to be. So here, 2 and a 30 will be 15, 9, and 17. So negative 15 plus 9i over 17. The last two, just a couple more divides because they make really good test questions. 1 minus 3i, 1 minus 3i. And just while I have the blue pen out, this one I'm going to go 3 plus 4i, 3 plus 4i. Okay, so for this first one, we're going to go 2 times 1 for 2, 2 times 3 for minus 6i, 5i on the inside, and then a 15i squared. And downstairs it'll be 1 squared plus 3 squared, a squared plus b squared. Cleaning all this up, I got 2 minus I, and then this is negative 1, so that makes that positive 15 over 1, and this would be 9, so that'll be a 10 down there. And 2 and 15 makes 17 minus I over 10. Okay, and this last one is another divide, so I'm multiplying by the conjugate. 5 times 3 is 15. 5 times 4 is 20i. 10 times 3, 30i. And on the outside I get 40i. Sorry, 40i squared. Downstairs, 3 squared plus 4 squared. Cleaning it up, I got 15 plus 50i. And then that'll be minus 40, because the I squared, over 9 plus 16. So 15 minus 40 will leave me negative 25 plus 50i over 25. So I can divide the 25 into 25 negative 1, because that negative, and 25 into 50 twice. Okay, that wraps up the review for exam 2.